Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about time response analysis. So basically, the time response analysis is based on input and output of the systems. If the output control system for an input varies with respect to the time, then it is called as a time response of the control system. The time response consists of two parts. First one is transient response and second one is steady state response. Transient response means the signals which is used to carry the input signal up to the final values, and steady state means it has to be reached based on the conditions, different conditions of a steady state. So normally the steady state response has been analyzed in the form of waveforms. So it can be represented transient and steady state response. It is calculated by C of t equal to CUT plus CM of t. So based on this, we can able to write the expressions. So here the C of t is the transient response, and the CSS of t is represented by steady state response. So based on this calculation, we can able to find the control system of the corresponding waveforms. And next one is it is based on a input control system and output time. Once if you are giving any information to the input signal, then automatically it just pass towards the end. After that, we can able to find the corresponding output of the concerned systems. So it has to be identified based on the transfer function of the system. So initially, the value has been varied with the help of input signals. It is to be set by steady state error, and moreover it can be applied to the limit to the concerned signals so that we can able to get the original signals. Example. So here they are given about CFT equal to 10 plus 5 into e power minus t. Initially we can able to take 5 into e power minus t will be a 0 at time t denotes infinity. So this is the transient term, and the first term remains even as the t approaches the infinity. So this is called as a steady state term. Standard test signals. So initially the signal has been analyzed based on the input signals. Here they are given about unit step impulse signals. Initially the impulse response has been analyzed based on the time signals. The time signals are based on the infinity of the concerned signals. It has to be identified by summation of 0 to values and L of t into dt equal to 1. If it is having some value, then based on the value it has been changed to the uh, concern given input signals. Unit step signals. So initially the unit step represent it is a 1. The value must be in this condition only, u of t equal to 1, t greater than or equal to 0. So this is the condition for unit step signal. If it is reach maximum 1 value, then it is automatically create an error so that we can able to eliminate the error based on the steady state response. Unit ramp signals. So the ramp means the value which will increases up to the maximum level. For example, if you are having a 5 value means, then automatically it just move towards the 5 value. Then we can able to fix the concern value as a final one. After that, we can analyze that it will be increased or not. So based on the values, we can able to check the corresponding input value by r of t equal to a into t. So here the A represent, we can able to substitute more number of values in A up to maximum level reach t greater than or equal to 0. So like that we can able to calculate for this unit ramp signals. And parabolic signals, generally it can be applied for many input signals at a single time. So it can be represented by P of t equal to t square by 2 t greater than or equal to 0. Up to this condition, we can able to use this value. The instantaneous value varies as the square of the time from an initial value of 0 at a time t equals 0. Suppose if it is having values like p of t is r of t is noted as a of 18 square by 2 t greater than or equal to 0. So based on the t value, we can able to fix the corresponding value as for unit parabolic signals. Suppose the value is given as 5 means based on the time signal we can able to calculate by 5 into t square by 2. So from this, we can able to check this value as a final one by using this unit parabolic signal assessment. How the test signals varies with the parabolic signals, because we are having a lot of values which is to be composed based on this parabolic signal only. So here the signals can be varied with other parabolic signal, means it represented by when a signal gives a constant acceleration distinctions of actual input signal, such as a signal is known as parabolic signal or parabolic function. It is also known as unit acceleration signal. The unit parabolic signal starts from t equal to 0. A parabolic signal is the one, the standard test signal. Parabolic signal is the signal whose magnitude varies as a square of the time. It is represented by P of t. Mathematically, the P of t will be t square by 2 and then t greater or equal to 0. The maximum, it is a positive value, and will be 0 t less than 0 for negative value. So based on this two value, we can able to set the initial value as t square by 2. So from this, we can able to find the number of information given to the input signal. So based on this parabolic signals. Thank you.